Hello and welcome. Today's lesson is 2.5, solving equations with involving absolute value. Let's get started. Today's objective. Previously, we learned how to solve equations with a variable on each side. Today's objective, what you need to write down, is that we are going to evaluate absolute value expressions and also solve absolute value equations. Again, just a reminder, pause the video at any time. Make sure you have the objective and vocab and examples all in your notes. So let's get started. There's actually no new vocabulary for this section, but it is important that you know what absolute value is. And absolute value is the distance away from zero on a number line. Absolute value can also never be negative. Keep those in mind when you're solving these problems. Let's get started with example number 1. Example number 1 is expressions with absolute value. So if I have the absolute value of a minus 7 plus 15, all we're doing is we're taking 5, whatever the given value is, and substituting it into our expression and solving. So the absolute value, 5 minus 7 is negative 2. And the absolute value of negative 2 is 2. And 2 plus 15 is 17. So that is how you evaluate with absolute values. So what I want you to do next is we are at a checkpoint. So pause the video, solve for or evaluate this expression, and save your answer to be later recorded on your Google form. Let's move on. Absolute value equations. What you need to remember with these is that there's always going to be two answers or two cases to consider. The first one is when the expression inside the absolute value is positive, and the second equation or case would be the expression inside the absolute value symbol when it is negative. So let's get started. We are solving absolute value equations. All right, so if I have the absolute value of 2x minus 1 equals 7, I have two cases to consider. The first one is I'm going to rewrite the problem without the absolute value equations. The absolute value sign. I'm going to solve this equation for x. I'm going to add 1 to both sides. I'm left with 2x on this side and 8 on this side. Divide both sides by 2, and you get x to equal 4. So I'm going to plug that back in. 2 times 4 is 8, and 8 minus 1 is 7. The absolute value of 7 does equal 7. I also need to solve it again, 2x minus 1, but instead of it equaling a positive 7, we're going to set it equal to a negative 7, and I'll explain why in a minute. We're going to add 1 to both sides. On this side, I'm left with 2x, and on this side, I'm left with a negative 6. Divide both sides by 2, and I get x to equal a negative 3. And here's why you're going to have two answers. Because when I plug negative 3 back up into my original equation, 2 times negative 3 is negative 6, and negative 6 minus 1 is a negative 7. Well, the absolute value of negative 7 also equals 7. So that is the reason why when you solve these absolute value equations, you're going to always have two answers. Okay, they then want you to graph it on a solution set. I kind of didn't give myself much room, but basically you are going to just graph these 2 points on a number line. So we have negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. We're going to place 1 dot there and 1 dot there. Let's move on. As you can see, negative 3 and positive 4 on a number line would be how you would graph it. Let's try another one. I have p plus 6 equals a negative 5. The absolute value of p plus 6 equals a negative 5. And there's something goofy about this equation right off the bat. And it is the fact that absolute value is set equal to a negative. Now in the previous example, we did solve it setting it equal to a negative, but the original equation was not set equal to a negative. There is no number that I could put in for p that would give me a negative answer. So if you ever see an equation that's set equal to a negative 5, your answer would be no solution. Okay? In the back of the book, it's gonna look like that, also known as an empty set. There's no possible way that an absolute value would ever equal a negative 5. So keep that in mind when you're going through the assignment and going through the problems. If you see any of them that are set equal to a negative, right away it should be a red flag that there's no solution. So we are at another checkpoint. Pause the video, try the problem. Notice that it's set equal to a positive 5 this time. So you're going to solve it in 2 different cases, and you're going to have 2 answers graphed on a number line. Excuse me. So take a moment, pause the video and solve it, and we'll come back and solve it together. All right, so my first case is going to be 2x plus 3 equals 5. And my second one is going to be 2x plus 3 equals a negative 5. So I'm going to solve this one over here. I'm going to subtract a 3 from both sides to start. On this side, I'm left with a 2x equals a 2. Divide both sides by 2. And I get x to equal 1. 2 times 1 is 2, and 2 plus 3 is 5. The absolute value of 5 does equal 5. Now I'm going to come over here and solve this equation. I'm going to subtract a 3 from both sides. I'm left with 2x equals a negative 8. Divide both sides by 2. And you get x to equal a negative 4. So I'm going to plug that one back in. 2 times negative 4 is negative 8. Negative 8 plus 3 is negative 5. But the absolute value of negative 5 is also equal to 5. So I have a solution of 1 and negative 4. So down here on my number line, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, negative 4, and 1 are going to be the 2 numbers that you are going to shade on your graph. Hopefully you got the same answer as I did. Let's move on. We are on to example number 3, which is a real world example. Solving an absolute value equation. The problem reads that the average January temperature in a northern Canadian city is 1 degrees Fahrenheit. The actual January temperature for that city may be about 5 degrees warmer or colder. Write and solve an equation to find the maximum and minimum temperatures. So the first thing that I would do is choose the method of graphing. T minus 1 is this equation. Here was my original temperature, and the 5 represents that it's going to move 5 in either direction. Notice that the distance away, we started with 1, we moved 5 higher and 5 lower on our graph, and our 2 solutions were negative 4 and positive 6. So those are your 2 answers for what the weather would be if you started at 1 degrees, but then fluctuated 5 degrees warmer or 5 degrees colder. This is at a checkpoint. Pause the video. We'll come back together and solve this one together. Alrighty, hopefully you paused the video and you have an answer for this problem. I'm going to just use X for my variable. My original temperature was 45 degrees. So that's going to go inside my absolute value symbol. And it says that the temperature varied from the average temperature by 15 degrees. So again, similar to the problem previously, it can be 15 degrees hotter or 15 degrees colder. So on my graph, I'm going to start out at 45 degrees, and I'm going to go up by 5. So 50, 55, 60, and I'm going to go up 5, 10, 15 degrees. And then I'm going to go down 15 degrees. So 40, 35, and 30. Your two solutions would be positive 30 and positive 60 degrees Fahrenheit. So those would be the maximum and the minimum temperatures for this problem. Hopefully you got the same solution. Example number 4 is kind of doing the opposite of examples 1, 2, and 3. We are going to write an absolute value equation. So they're going to give us the graph, and then we have to turn around and write the equation. So the first step is to find that middle point. Okay? So they give us our 2 points, and I need to find the point right in the middle. So if I go up to 4, I can only go to 4 here. It looks like 1 is my middle point. Okay? So in your absolute value equation, it's always subtracted by that middle value, which in this case is 1. And it equals the distance away to each point. So to get from 1 to 6, I'm going to hop 1, 2, 3, 4, 5 spaces. And to get from 1 to negative 4, I am also going to go 1, 2, 3, 4, 5 spaces. So 5 is the distance to each point, and 1 is the middle point. Does that make sense? All right, let's try another one. Again, this is just explaining the previous problem. The distance from 1 to negative 4 was 5. The distance from 1 to 6 is 5 units. So the equation again was the absolute value of y minus 1 equals 5. So this next problem is going to be answered on your Google form. So take the time, try it on your own. Again, step number 1 is to find the middle, and then step number 2 is to find the distance away to each point. It should be the exact same on each side. Okay? Go ahead and take the time to answer it. This is actually the last example, the last problem for today's lesson. If you have any questions, come tomorrow with them, and we will discuss it more in class. Have a good night.